So the last two sections of this chapter, and you can do a little dance if you're excited that it's almost over. The last two sections of this chapter are kind of dedicated to more of the graphing parabolas. So in the last, I don't know, 3 or 4 sections, we've talked about solving quadratic equations and their applications. But remember the very first section of this chapter, we said, okay, we're going to learn how to solve quadratic equations, but the whole point of that is because those correspond to the x-intercepts of a parabola, which is the graph of a quadratic function. So that's kind of what we're focusing on now. Now that we know how to solve these equations, we can find we can find x-intercepts and all that easily. So we're kind of tying it all together and looking at the big picture in this section and the next one. So okay, quadratic functions and their graphs. So just to get the hang of it, we'll kind of have a kind of shortcut or easier way to do this. But for this first example, just to get a feel for, if you're given a function like this guy, then how does the graph look? And are there any clues like this number 2 and this number 3? Will those maybe give me a clue as to how this graph looks, But this one, we're going to just do it the old-fashioned way. If you don't know what a graph looks like and you have no idea how to graph it, the best thing to do is just start plugging some values in. Like I have kind of a wide range here from -2 all the way to 4. I'm going to plug those in this function and see what values we get. And we'll think of those as ordered pairs or points and we'll plot them. And then I think we'll see a parabola forming and it'll work out pretty well. But if at this point you're thinking, wait, aren't these quadratic equations or functions we're dealing with usually looking like this? ax squared plus bx plus c? And this one doesn't quite look like that. What's with the parentheses? Well, what we'll find out is that it's easier to graph a quadratic function when it's of this form that we're given here with parentheses. These ones here we'll see in the next section, ax squared plus bx plus c. If it's in that form, it's a little more difficult to graph. So right now we're kind of dealing with the easier nice ones, and then in the next section we'll see what do we do as far as if we're given something that's not nice. Although, if you're thinking, are these even the same thing? If you think about this function here, it's x minus 2 squared plus 3. You could always make this guy look more like ax squared plus bx plus c if you wanted to. You can multiply this out, because x minus 2 squared means x minus 2 times itself. And if you FOIL that out, you get x squared minus 4x plus 4 plus 3. And then once you combine these guys to make that a 7, it does look more like ax squared plus bx plus c, So the problems we're given in this section really are what we've been looking at. They just have this nice form, and we'll have to figure out in the next section, if they're not in that nice form, how do we put them in that nice form? Because they're way easier to factor than something that looks like ax squared plus bx plus c. So anyway, let's see what this graph looks like, and then we'll see if we can get any clues from it, and then we can graph things easier from there. So let's see, I'm just going to start from the top here. I'm going to plug in -2 and see what happens. So f of -2, what if I put a -2 where x is? It would be -2 minus 2 squared plus 3. Okay, that's -4 squared plus 3, which is 16 plus 3, or 19. Uh-oh. That's going to be off the charts, huh? Way off the charts. Oh well, that's okay. Now let's try the next value, -1. If you're really good, you might be able to plug these in your head, So if I plug -1 in, that's -1 minus 2 squared plus 3. Well, -1 minus 2, that's -3 squared plus 3. -3 squared is 9. 9 plus 3 is 12, so that's going to be 12. And the next guy, that one's a little easier because 0 always makes things nicer. If I put 0 in there, f of 0 is, and again, you're just plugging these into this function here. Just take this right side of the equal sign and replace x with the value, this time 0. 0 minus 2 squared plus 3. That's -2 squared plus 3, which is, let's see, what's -2 squared? That's +4. Okay, and +4 plus 3 is 7. There we go. Now let's try 1. Then if you get, at this point, if you're kind of getting the hang of this and you're saying, I could just plug these in my head and not really write it out, don't feel like you have to write it out. You can just kind of plug these in your head and see what happens. If I replace the x with a 1 this time, it'll be 1 minus 2 squared plus 3. 1 minus 2 squared is -1 squared. -1 squared is 1. 1 plus 3 is 4. So that value is a 4. All right, the next guy, what do we have there? I'm plugging a 2 in. F of 2, I'm replacing 2 in that function where x was. So it would be 2 minus 2 squared, that's 0 squared, plus 3. 0 squared is 0. 0 plus 3 is 3. There we go. All right. So far, so good. I think we're getting there. And the next guy, we're almost done. I plug a 3 in. F of 3 is replacing the x with 3. 3 minus 2 squared plus 3. 3 minus 2 is 1. 1 squared is 1. And 1 plus 3 is 4. All right, got one more. And then I think once we plot all these points, we'll have a good idea of how these graphs look. This last one, I'm plugging a 4 in. It'll be 4 minus 2 squared plus 3. See, 4 minus 2 is 2 squared plus 3. 2 squared is 4 plus 3 is 7. All right. So one thing you kind of notice, I don't know if you noticed this, but kind of the smallest y value or f of x value we got so far is 3. I noticed from there the other values kind of surround it. Look at 4 on either side of it. And then you have 7 on either side of that. And then I'd imagine 12 is probably on either side of that. So it's kind of, you see the values repeat, but the very smallest one is right in the middle. The 3 is the smallest one. Let's see if we can plot those points, though, in this big graph over here. So although I didn't really leave a lot of room, you know what I might want to do just for fun, just so I can see all those values, is extend that graph higher. Because notice right now it's only going up to 10. I'm going to try to do my best to try to make it go up to something higher. 11, 12, 13, 14, 15, 16, 17, 18, 19. That might make, because I notice I have some really large y value. The very first guy I have, this ordered pair here, negative 2, 19. So the x value is negative 2, that's here, and then 19 is way up. I think that's as far as I went up here. So there's my first point, thinking of that as 19 right there. The second point, negative 1, 12, that'll be to the left, negative 1, and up 12. That's 10, 11 here. All right, the next point, 0, 7. It's right on the y-axis at 7. And the next point, 1, 4. That's to the right 1, up 4. There he is. So at first, those points were kind of looking like they were in a straight line, but I can kind of see it curving now. Maybe it's going to make that U shape that the parabola is supposed to have. The next point, 2, 3. That guy would be to the right 2, up 3. So these are kind of getting closer together, and they're definitely rounding out, I can tell. The next guy, 3, 4. So right 3 and up 4. Now it's starting to, instead of decreasing, it's going to start increasing now. And the last point, 4, 7. So to the right 4, up 7. All right, so I can kind of see if you kind of squint at that hard enough. What if you connect those dots? You got connect these guys, connect these guys, connect these, connect these. It does look like a parabola. And even though these are the only points I plotted, if I were to plot more, it would make this kind of go up forever. And it would go up forever on both sides. Okay, notice, so I guess one of the distinguishing characteristics of a parabola is this lowest point here, or I guess if it's an upside down parabola, it's the highest point. But they call this point the vertex. It's kind of like the base of the parabola, you know, where it starts, and then from there it goes up on either side. But what point is that? If you kind of look at, it's above 2 on the x-axis, so it has x value 2, and it's across from 3 on the y-axis, so it has y value 3. And notice that the original function we started with, it was x minus 2 squared plus 3. So I think that gives us a clue as to what the vertex will be. We're going to make a kind of a generalization about that. The number here and the number here will tell you the vertex. It's just that you notice this sign in the middle right here, it's x minus 2. So I see a minus, but there is no minus on the vertex. So I'll have to worry about that. If there's a minus there, you don't... Anyway, it's not part of the vertex. So we got that. The vertex is 2, 3. And then the other thing to notice, I guess, is that parabolas are symmetric. If you draw a line, a vertical line kind of right through the vertex, the left side and the right side should be mirror images of each other. That's kind of how parabolas work. It should be symmetric, yeah, on either side. Almost, yeah, like, imagine that line I just drew, that vertical line, as a mirror. The left side and the right side should be mirror images. They call that line the Axis of Symmetry. And that's kind of important because if you know what the left side looks like, you'll know what the right side looks like. You just kind of draw the mirror image. And if you know what the right side looks like, you'll know what the x side looks like. But what would that line be? Remember that lines, of course, they have equations y equals mx plus b, but vertical lines have equations x equals something. So remember that? Yeah, the horizontal lines have equations y equals something. Horizontal or vertical lines like we have equation x equals something. And the something is just where it intersects the x-axis. And this guy intersects the x-axis at 2. So it's interesting. Notice, yeah, the axis of symmetry, it's x equals the same number that was the x value of the vertex. So those will be kind of our generalizations. Now, from now on in this section, whenever we're given any kind of quadratic function, we're not going to have to graph it with this table anymore, because we can kind of draw some conclusions about what we see here. That the vertex, the values of the vertex 2, 3, came from the values of the function itself. It was x minus 2 squared plus 3. So this in this box here, we're kind of making some generalizations and kind of making it so we won't have to make a table of values ever again. So, okay, if you're graphing f of x equals something of this form, maybe in this one we didn't see, there was nothing in front of the parentheses here, if you notice. But if there was something in front of the parentheses, that wouldn't change it too much. And then x minus some number squared plus some number. So the first thing we can say is that the vertex is h comma k. So like we saw, the number inside the parentheses with x is h, and the number adding at the end is k. And the axis of symmetry is x equals h. So x equals the number, the x value of the point. Okay, but notice this is something I would want to point out because it's kind of confusing. Kind of like we saw with the function above, the number inside the parentheses with x there, when you look at x minus 2 squared plus 3, it looks like it's a negative 2, but actually for the vertex it ended up being positive 2. So what you want to do is change the sign of h. So whatever sign you see in the parentheses for your function, if it's negative, make it positive. When you declare what your vertex is, if it was positive, make it negative. But notice the value of k, the y value of the vertex, it was positive 3 here, and it stayed positive 3 when I wrote my vertex. So you're going to keep the same sign for k. That's kind of confusing to remember, but gotta write that nicer. Yeah, that if you look at the numbers that are sitting there with x in your function, it's going to tell you the vertex, but the vertex x value, you have to change the sign. The y value, you do not have to change the sign. So that's one thing. And then the second thing that we notice, if you were to graph more of these, if there happened to be a number in front of the parentheses, like, notice here, if there's a number in front of the parentheses, the graph will open upward, like we see in our graph. Notice it's a parabola that opens up. It's kind of like an upward U shape. It'll open upward if that number is positive or greater than 0, and it'll open downward if that number is negative. So that's another way to say it. It's kind of easier to think of it that way. If that value of a, the number in front of the parentheses, is positive, you'll see an upward parabola like that. But if that value of a is negative, that's just another way of saying less than 0, right? Then it'll be a downward parabola, like an upside down U sort of. Okay. So it'll pretty much tell us everything about the graph, because if you know where the vertex is, you'll kind of know where the graph starts. And then if you know whether it opens up or down, then you pretty much know the graph. The only thing we're missing now is how wide or how narrow these things are, because that value of a will actually matter. If a is a large number, it'll be a really narrow parabola. If it's If it's a really small number, it'll be a wide parabola, which kind of is counterintuitive. But the easiest way to do it, and the way the homework wants you to do it, is, like it says in this third bullet point here, to determine how wide or how narrow the graph will be, you just substitute any value of x you want, but of course not the vertex value, because you already know that point's on the graph. You want a separate point, and you'll find another point. But what I'd say is you want to keep the value that you choose to plug in somewhat close to the vertex. Because if you choose, let's say, like, if I picture my graph above this guy, what if I choose an x value, let's say way out here? I said, oh, I'm going to plug in -6 and see what happens. Imagine where that value would be. This parabola is going up forever. I mean, this -6, you're not going to see a point on there until you're really high up. So I wouldn't do that, because you're going to get an x, or when you plug an x value like that in that's really far from the vertex, like this guy's fairly far, you're going to get a huge, huge y value, and it's going to be way off the charts, and you won't even be able to graph it. So yeah, when we're graphing these, you want to find the vertex, that's one point, but you need one extra point, which you'll find by choosing an x value and plugging it in, But you want to make sure the x value you choose isn't too far from the vertex, because if it's far away, it'll be way too big. So we'll be graphing them eventually, but let's see, just for this next example, we're just going to practice looking at a certain quadratic function and identifying what is the vertex, and then whether the graph will open upward or downward, too. You know what I might add on there? Because I think sometimes the homework cares. And also find the axis of symmetry. So I kind of forgot to say that. They're going to want you to do that. Alright, so let's look at part A. Remember, they said the vertex is going to be h comma k. I'm just kind of going off this the first bullet point here. H comma k, and notice in their general quadratic equation, it looks like a times x minus h squared plus k. So since your vertex is h comma k, the x value is h. That's the number inside with x. So it's going to be, yeah, h comma k, where h comes from this number inside with x, and the k comes from the number at the end. But remember, like we kind of wrote down as a note, you change the sign of h. So since it looks like a negative 2, I'm actually going to put a positive 2. And then the k, you do not change the sign. Since 7 is positive, I'm keeping it positive. So keep that in mind. You want to change this guy's sign, h, but this guy you want to keep his sign. Whatever it was, keep it the same. So that's the vertex of that parabola. And then, okay, they didn't mention this in the example, but I know they're going to ask this in the homework. The axis of symmetry, in that same first bullet point, they said the axis of symmetry is just x equals h. So all I have to do is say, well, h is the x value of the vertex, so it must be x equals 2. And that's it. So really, once you have the vertex, the axis of symmetry is easy. It's just x equals the x value of the vertex. Easy peasy. And then the last part of this that they want us to determine is, does it open upward or downward? Okay, but remember the value of a is the coefficient of the parentheses, I guess, is what you can think of it as. What's the number in front of the parentheses? Parentheses. I guess I don't see anything in front, so it must be a 1. And then all you have to do is say, okay, is that number positive? If it's positive, it opens upward. If it's negative, it opens downward. But since that's a positive number, this parabola opens upward. There we go. So those are the 3 things they want. And that'll pretty much tell you how the graph looks, those 3 things. It just takes some practice getting used to this. It's kind of confusing. Let's try part B now. So part B, same thing. You can find these 3 things in any order, but I'm just going to keep them in the same order. The vertex, remember, is h comma k, where h is the number inside with x, but remember you change his sign. So since the number inside the parentheses with x, it looks like a negative 3, I'm changing it to positive 3. And then the number just hanging out at the end, adding or subtracting, is k, and you do not change his sign. So since it's negative 4, I'm going to keep it negative. So it's hard to remember. I wish they were both the same sign, or even you change both signs. It's hard to remember you change the left number sign, but don't change the right number sign. Ugh. Okay, then the axis of symmetry, remember it's just x equals h, where h is this number inside on the x value of the vertex. So that part's pretty easy. And then now, the last part is you want to tell if it opens upward or downward. And that'll involve telling me what's a here. And like we kind of wrote out in part A of this problem, a is the coefficient of the parentheses. So here we actually have a number in front of the parentheses. It's negative 2. And like it says in that third bullet point, it says if that number is negative like we have, it'll open downward. So this would be an upside down parabola where the vertex 3 comma negative 4 must be the base value of this vertex, or of this parabola, sorry. Not that they asked us to graph it, it's just kind of helpful because we'll be graphing them soon. Alright, we got everything they want. Now let's look at part C. So again, the vertex, that's going to be h comma k, where h comes from the number inside the parentheses, but you change its sign. Since the number inside the parentheses is positive 1, I'm changing it to negative 1. And k is the number adding or subtracting with the parentheses, and you don't change its sign. Since it's positive 5, I'm keeping it positive. There we go. Okay, that's good. And then the axis of symmetry, Remember, that's just x equals the x value of the vertex, -1. And in this one, our value of a, the coefficient of the parentheses is 2/3. Doesn't really matter what it is, it's just, is it positive or negative? Well, I don't see a negative sign, so it must be positive, which means that this parabola opens upward. There we go, so we got it all. The vertex, the axis of symmetry, and it opens upward or downward. Perfect. All right, let's try a couple more of these, and I think we'll have the hang of it. Just have the hang of identifying the vertex and that kind of thing, and then we'll be ready to graph some of these guys. So part D, all right, what do we have? -1.7 x minus 4 squared. All right, the first thing we usually want to find is the vertex. And that's going to be h comma k, where the value of h comes from inside the parentheses with x, but I changed its sign, so since it was -4, I want +4. But you notice k, usually you find k hanging out at the end of the problem, but there is none. K should be the thing adding or subtracting with the parentheses, but there's nothing adding and subtracting. And it won't be this 1.7 because that's the value of a. It's the coefficient. It's not something adding or subtracting. So since there is nothing adding and subtracting, it'll be a 0. That's the vertex. And then our axis of symmetry must just be the line x equals the x value of the vertex, 4. And then our value of a, the coefficient of the parentheses, is -1.7. Which it doesn't really matter what the number is, it just matters if it's negative or positive. It's negative, so it opens down. There we go. Gotcha. Alright, I think we're getting the hang of this. So part E, this one looks kind of weird. The vertex is supposed to look like h comma k, where h, remember, is what's in the parentheses with x, but it's nothing inside the parentheses with x. Because remember, it's supposed to look like x minus h squared. So it's kind of like h is also being squared along with x, but we have nothing being squared along with x here, so h will be 0. So it's kind of like whichever one's missing, h or k, you'll let that be 0. But then k is -3. You see that's something adding or subtracting at the end. And remember, k, you do not change the sign, it stays the same. And then we have the axis of symmetry. That's going to be x equals, the x value of the vertex was 0 this time. And then lastly, our value of a, the coefficient of, well, usually the coefficient of parentheses, or the coefficient of what's being squared. It's 14, which who cares what the number is, as long as it's positive or negative. It's positive, so it opens up. All right, perfect. Let's see now. This last one here, it looks kind of tricky, because you notice, okay, I want the vertex, h comma k. I can see h will be the thing inside the parentheses with x. But then k, wait a second, isn't k usually here? You notice, I think in this one they switched things around on us. They took two terms and they switched them. I think what I'm going to do is take this guy 3 and this big -2 blah 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 and switch them around. I want to put the -2 x plus 9 squared and then the 3 that's in the front. So they're pretty much like they took one of these guys, imagine part C, and they switched them, like they put the 5 first and then the 2/3, yada yada yada. So someone's trying to trick us here, but we can't be tricked. We're gonna, if you ever see that thing adding and subtracting in the front, I'm gonna put it to the right side because it's too, I want it to look more like, you know, like it's supposed to look anyway. All right, now that we have it in the right form, I think it's easier to identify the vertex. H comma k, where h is the number that's inside the parentheses with x, but it's opposite sign, so -9. And now I can see k is on the right side now that I've moved it, and I don't change its sign. Then the axis of symmetry is going to be x equals, the x value of the vertex is -9. And then the last part, the value of a, you know what, I might have gotten confused if I left it as is. I would have thought, wait, is it the 3 or the 2? But now that I have it like this, I can tell the coefficient of x squared, or the coefficient of the thing being squared, is -2. And all that matters is that that's a negative number, so this parabola would open downward. Alright. So probably you got the hang of it by now, just to kind of, it's kind of confusing, you know, trying to remember that the vertex, you change the sign of the x value, but you don't change the sign of the y value. It's confusing, but hopefully now it makes a little more sense, and it'll be a lot easier to graph these guys. Alright, but what we really need to graph these guys is let's see, the vertex first. So let's see, looking at example 3, part A, I'm going to first identify his vertex. And I think by now we're pretty good, so I'm just going to write it out. The h value is 4, I change its sign. The y value is 1, I don't change his sign. So that's that. And then what else do we need? The axis of symmetry will be pretty helpful. It's going to be x equals the x value of the vertex 4. And then I have to determine, is this opening upward or downward? Well, the value of a is the coefficient of the parentheses, which is 1. That's positive, so it's going to open up. We got that. All right. But as it says, okay, let's say, I don't know, that's actually not enough to graph it. Notice, we haven't talked yet, in the previous example, we haven't talked about that second bullet point that was way above. Where was it? Way up here. Remember the second bullet, not the second one, sorry, the third one. We need to know how wide or how narrow this thing is. We didn't kind of talk about that in example 2, but now that we're graphing it, we do need to know. So we're going to need to find one more point besides the vertex by substituting some value in. I'm going to try that here for this part A of example 3. But like it says, you're going to choose any x value you want and plug it into this function. But what you'd like to do, it's going to be easier if you choose an x value somewhat close to this guy, 4. So maybe I'll choose like 2 or 3 or 5 or something. I'll try 2. It doesn't really matter. Like, I'm going to try or plug in, x equals 2, but you can plug in x equals 3 because that's even closer to the vertex's x value. Or 5 is close, or 6, something that's close to the x value of the vertex. Doesn't really matter. Your graph will end up being the same no matter what you choose. Yeah. Okay, so I'm going to rewrite that function, but I'm going to leave x blank. F of x, but I'm replacing x with 2, is x minus 4 squared plus 1. All right. But where the x was, I'm replacing it with 2, and then seeing what happens. Let me see. I'll simplify that. That's 2 minus 4 is negative 2 squared plus 1. That's 4 plus 1, or 5. Okay, so that gives me a second point. The x value was 2 that I plugged in, and I just found that the y value is 5, or the function value is 5. So now I have 2 points to plot. That's good. Alright, it doesn't matter which one you plot first. I mean, I guess the vertex came first, so I'll plot that guy. There's the vertex. And the point I just plotted was 2, 5. There he is. Aha. Okay, and I know that this thing is opening upward. So I'm just going to go ahead and try to do my best to graph a parabola that starts at that vertex and opens upward from there. And try to make the left side and the right side look like mirror images of each other. I guess keeping in mind that the axis of symmetry goes right through the vertex. Remember, this is the line x equals 4. So I try to do my best, but it doesn't really look symmetric, huh? If you're kind of a perfectionist, you might erase it, but I'm not too concerned with it. As long as it looks like you put some sort of effort in, that looks a little better. There we go. So there's my point. And if you had, I plugged in x equals 2 to find a second point. Let's say you'd plugged in x equals 3 or something. Then your point would have been about right here. So don't worry. Even if you plug in a different point, you're going to get a point that's still on the parabola. So you're going to have the same shape and the same graph. Just the second point you find will be a different point. It'll just be the same parabola. That's all. Alright, I think so far so good. We're doing pretty good here. Let's try this next one. Part B, what do we got? First thing you want to do, just like in the last one, you want to say what the vertex is. So here the vertex, the value of h is 5 because you change the sign. The value is k is negative 3 because you don't change the sign. And then the axis of symmetry is going to be x equals the x value 5. Alright, and then this parabola I can tell is going to open upward because the value of a is 2, which is positive. So it's going to look similar to the last one. It's not going to open downward, it'll open upward. But now I need to find just one more point. And I can choose any x value I want to plug into this function, but I'm going to try to choose something somewhat close to 5. Maybe this time I'll choose 6, just for fun. It doesn't matter, you choose 4, you choose 3, you choose 7, but just for fun I'm trying to mix it up. I want to plug in x equals 6 into the function. The function is f of x equals 2 times x minus 5 squared minus 3, but I'm putting a 6 in there. Let's see. Alright, and we'll simplify this guy. That's 2 times 6 minus 5 is 1 squared minus 3. And 1 squared, of course, is 1. 2 times 1 is 2. 2 minus 3 is negative 1. Okay, there it is. So we chose an x value of 6 to plug in, and we got negative 1 back. So there we are. Let me plot these points. It doesn't matter which one you plot first. The vertex was 5, negative 3. That's over here. And the second point I found was 6, negative 1. That's here. Alright, and I can see this thing's going to open upward because we've already decided that. I'm going to draw the axis of symmetry right through the vertex, that line x equals 5. Just so I know, if I know what one side looks like, the other side will be the mirror image. Because I know more about the right side of this than I do the left side. Because I have 2 points on the right side. The left side I know nothing about, but at least I can try to make it a mirror image here. Try to go, kind of make it as wide or as narrow as the right side is. I think that looks good. And yeah, on the homework, they'll make it a lot prettier. You just give them the vertex, and then you give them the second point, and they'll make it perfect. It's kind of nice. Alright, we're almost done. We've just got a few more to practice. So this next guy, part C, you have your vertex is h comma k. H is negative 2, k is 7. That means your axis of symmetry is going to be x equals the x value of the vertex, negative 2. And because the value of a is negative 3, that's negative, it opens down. So notice when you graph these guys, you're not really using the opens up or down. It's just kind of a check. Once I connect the dots of my graph, is it actually opening the way it should? So if I connect the dots of this graph, and it seems like it's opening upward, then I know something's wrong because it should open downward. Okay, the last thing to do for this one before I graph is finding one more point. So I'm going to try to find, plug in an x value close to the vertex value. And the vertex's x value is negative 2, so maybe you can do negative 1 or 0. I like 0. Whenever 0 is close, I always pick it because it's really nice. But again, you can choose whatever you want as long as it's somewhat close, and you should get the same graph. So I'm going to rewrite this guy, but leaving it blank where the x was, and I'm going to replace x with 0. And we'll simplify that. Okay, what's this guy? It's negative 3 times 0 plus 2 is 2 squared. And be careful, you got to use order of operations. 2 squared is 4. You can't do 3 times 2 first. Negative 3 times 4 is negative 12. Plus 7 is negative 5. Alright, so that point must be 0 because I plugged in a 0 for x, and then negative 5 because I got a negative 5 out. Alright, I'm going to do the vertex first though. Negative 2, 7. Where's that? Negative 2, left 2, up 7. There he is. And then the other point I found was 0, comma negative 5. That would be, whoa, way down there. Wow, look how far apart those guys are. Crazy. So I can imagine if I had picked an x value even further away from the vertex, it would be probably off the charts. So it's good I chose one somewhat close. And the axis of symmetry is the line that goes right through that vertex. Alright, if I connect those dots, at least on the right side, it looks like this is going to be a downward parabola, right? If I connect those guys. Which is good, because that's what we decided earlier. And now I'm going to try to make the left side look as much like the right side as I can, as wide or as narrow. You know, do your best. Don't stress over it too much. I think that looks pretty good. Alright. Let's try this next one here. This guy's kind of interesting. The vertex of this guy is going to be h comma k, but notice there is no h, so it'll be 0. K is negative 1, because remember h is supposed to be a number that's inside the parentheses with x, but there is no parentheses with x. And our axis of symmetry is x equals 0, because that's the x value of the vertex. And this thing will open down, because the value of a, excuse me, the coefficient of x squared is negative. So I can expect this thing to open downward. Now we're going to find one more point. We're going to plug in whatever x value we want. Try to keep it close to 0 though. And I love 0. I wish I could plug 0 in again. But you know, if I plug 0 in again, I'd get the same point, the vertex again. So it'd be a waste of time. I'm going to plug in 1. I like 1. He's pretty good. So f of 1 is negative 3/2 times 1. You know what, though? Now that I'm seeing this guy, think about what's going to happen here. If I put a 1 in there, okay, 1 squared is 1. But then 1 times 3/2, that's not going to be pretty. So you know what you might want to do is think about what kind of number can multiply by a fraction like this and give me a nice value. You know when it would be nice is if this, whatever this ended up being, and this 2 reduced a little bit. So maybe I'll make it an even number like 2. That might not be a bad idea. If that makes sense. Because notice if I put a 2 in there, I'll square 2, and that'll be an even number. And when I multiply an even number by that fraction, I'll get a whole number, which is nice. So I might do that. You don't have to. I mean, your answer would be a decimal or a fraction otherwise, but it's probably a good idea. So let me see. This is negative 3 halves times 2 squared is 4. Okay. And when I multiply 4 by 3 halves, I'm going to put the 4 over 1. And if at this stage you can see it's not reducing, then you might want to go back and change your value from whatever it was to something nice. So this will reduce to just negative 3 times 2, which is negative 6, and then minus 1 is negative 7. That's nice. X value was 2 I plugged in, and the Y value is negative 7. Otherwise, I think if you get a fraction, it'll be hard to plot, especially if you're doing the homework, because the homework, you're going to have to find that point on your own. You're going to have to plot it. And if it's like 2 comma 1.47, well, you can't really find that exactly. So you kind of, if you see a fraction in your function, you might want to strategically choose the x value so that you'll pop out with a nice x value or a nice y value. All right, our vertex was 0, negative 1. That's right here on the y-axis. And the second point we found was 2, negative 7. Where's that? Right about here. All right, and then our axis of symmetry was x equals 0, which is basically the y-axis. All right, so whatever happens, this thing should be symmetric about that line. Let me connect these dots. All right, that looks good. I kind of missed that dot, but you know, it's the thought that counts. And now I can figure out what the left side looks like by trying to find the mirror image of that guy as best I can. Something like that, right? There he is, and it's a good thing it's opening downward because we thought it should open downward. Well, I think we're doing good. Hopefully it's making more sense. It's kind of, doesn't seem exact though, right? Because you're kind of, I don't know. It'll be more exact when the homework does it for you because they do it perfectly. Just do your best on these and don't worry too much about how perfect it is or how symmetric it is. All right, let's see. Part E. The vertex of this guy, h comma k. H is the value inside the parentheses with x, change its sign so it'll become negative 1. K, there is no number adding or subtracting at the end, so I'll put a 0. Okay, and then the axis of symmetry, it'll be x equals the x value of the vertex, negative 1. This thing is going to open up because the number in front, the a value, is positive, because positive 0.2. All right, looking good, looking good. Okay, so far so good. Now what? Now we need to plug in one more value to find another point. X equals, okay, this is one maybe kind of similar to the last one where I'd look at this and say, let's see. What can I do here? Because I don't like that 0.2, that's kind of worrying me. You can kind of picture, well, for sure whatever I plug in, I want it to be close to negative 1. Is there anything close to negative 1 that I can plug in that would make that nice? Ugh. Not really, huh? I think anything you plug in close to negative 1, you're going to end up with a decimal. So it's kind of up to you. I might just plug in 0. Because I think there's nothing really that's close to negative 1 that I could plug in that'll give me a nice whole number. So it's okay. I'll just see what happens. F of 0. Let me plug in 0. 0.2 times 0 plus 1 squared. Oh, man. 0 plus 1 is 1. 1 squared is 1. 1 times 0.2 is 0.2. That's not nice. So the x value is 0. Now I found the y value is 0.2. Alright, oh well. We'll try to plot those guys as best we can. And the vertex was negative 1, 0. Here he is. And then the point I found other than that was 0, comma 0.2. That's going to be barely above the origin, huh? I mean, I'm even making it ridiculously higher. Because it's 0.2 is a fifth of the way up to 1. Something like that. Ugh, that's not pretty. Oh well, and then, let's see, I'm going to draw the axis of symmetry was right through the vertex. There we go, there we go. Alright, and I can connect those dots. They're so close together though, it's kind of hard to tell. You just kind of do your best to round it out, make it look like a U shape. If yours looks a little wider or a little narrower than mine, don't worry about it. You're just doing your best. I mean, it's not going to be perfect. Now I'm going to try to make the left side look like a mirror image of the right side. Sure. That's good enough for me. All right, I like it. And it's opening up upward like we thought it should. Good. All right, last one. I think this one looks tricky. You notice this one, everything's kind of in the wrong order like it was in the last part of the previous example. Those examples where we weren't graphing, we were just kind of identifying vertex and all that. I think this one, what you want to do is move this 4 over to the other side of the parentheses. Because then I'll look like negative 1/3. Now I can tell that's going to be the value of a. X minus 2 squared and then plus 4. Oops. Plus 4. That's a lot better. Now I can see that's h and k and a and everything like that. Okay. So vertex is supposed to be h comma k. H is the number in the parentheses with x but opposite sign, so 2. And then k is the number at the end, adding or subtracting. Same sign. And the axis of symmetry is going to be x equals the x value of the vertex. And this thing is, I was having a hard time thinking, will it open upward or downward when it looked like it did before? But now that I see a is a negative number, I can tell it opens down. Yeah, because a is the coefficient of the parentheses, which is a negative number. All right, now we want to figure out one more value, so I'll plug in something. And this, I'm not too excited because I see that this function has a fraction. I think when I plug something in, if I'm strategic, it might come out nice, but if I just pick a random number, it might not work very well. And I want to plug in something close to 2. I mean, something really close to 2 is like 1. But I think if I put a 1 in there, I'll end up with a fraction, and that's not pretty. What about 0? If I put a 0 in there, that won't be pretty either. What about if I put a positive 2 in? Because I'm looking at that guy, looking at the x minus 2 portion, the thing in parentheses, and I kind of think, what if that ended up being 0? That would be nice, because then 0 times 1/3 is 0, and I wouldn't even have to worry about the 1/3. So I was kind of thinking, what can I plug in there that'll make that parentheses 0? So in other words, what minus 2 is 0? So I was thinking 2. And 2, I mean, it's sort of far away from this guy, but not too far. Let's see how it goes. If it ends up not working out very well, I'll try something else. I think that'll work. Hopefully that makes sense, though, why I did that, because when I plug that into this red portion here, x minus 2, I'll get 0. And then 0 times the fraction will make it disappear, and I won't have to worry about the fraction. I'll plug that guy in. Let's see. And if you plug in another number and if you realize it's not going to be pretty, you can kind of always start over and plug something else in. I'm going to try 2. Okay, that way here we have negative 1/3 times 2 minus 2 is 0, like we wanted, squared. And 0 squared, of course, is 0. And 0 times anything is 0. So it ends up just being 0 plus 4, which is 4. The point is 2 comma 4. That's almost too nice, especially because this function's really ugly, Wait, damn it, that's the same point. Damn it! You guys must be tired. Oh my gosh, that is the vertex. Dang it, you guys. Alright, let's try something else. Dang it. What if we do... Dang it. I was so excited. How about negative 1? Let's try negative 1. Dang it. You guys probably saw that from a mile away. You were thinking, what the heck is she doing? We already have that point. Oh my gosh. Well, it just goes to show you that, everybody can be silly. Alright, I'm going to try negative 1. I have a feeling that's going to work out alright. Okay, so negative 1/3 times that guy minus 2 squared plus 4. So for me, the reason I chose negative 1 is because I thought, I guess what would make this work out well is if whatever this is divisible by 3, because then they'll reduce nicely. So what kind of things are divisible by 3? I thought, well, if this is like a 3 or a negative 3, that'll work out. And I realized if I put a negative 1 in there, I'll get negative 3. So that's kind of what I was thinking. Whatever this denominator is, you kind of want to see a multiple of that once you plug it in, because then when you multiply a multiple of 3 by a fraction with a denominator of 3, it'll come out nice. Okay, when I combine those guys, negative 1 and negative 2 makes negative 3 squared. Negative 3 squared is 9. And 9 times negative 1/3, if I put the 9 over 1, it'll reduce to a whole number. Negative 3, or 3 with the negative there. So it's negative 3 plus 4, which is 1. And the x value I plugged in was negative 1, so it's negative 1, 1. That's pretty good. Alright, sorry I wasted your time with that earlier. That was silly. So the vertex was 2, 4. Where's that guy? He's here. And then the point we just found was -1, 1. He's here. All right. And then the axis of symmetry is the line x equals 2 right through the vertex. All right, and if I connect the dots, I kind of only know what the left side looks like that. And it is opening downward, so I'm going to keep it going all the way down. And I know nothing about the right side, but I'm going to try to make it look like a mirror image of the left side. There we go. Looks good. All right. So it's kind of a tedious section, you know, it's a lot of details, a lot of plugging things in and noticing vertex and all that stuff. I hope it made sense. The next section is just more of the same kind of thing. So I'll see you in the next section, and then we'll pretty much be done, huh? All right, thanks for listening.